Welcome back to the show. We have an incredible mission for today's deep dive. You, the listener, sent us an excerpted Wikipedia article covering a largely forgotten but honestly utterly massive chapter of aviation history.
Well, massive is definitely the right word for it.
Yeah, we're talking about the Riesenflugzeug today, the art planes, and looking at the virtual backdrop you've set up for us.
Ah, you like the dusty, sepia-toned hangar look?
I love it. It's perfect. We're just surrounded by these sprawling, incredibly complex blueprints of early 20th century biplanes and triplanes.
It really sets the mood, because to grasp the sheer, just the audacity of this era, we really need to anchor ourselves firmly in the years between 1915 and 1919.
Right.
When people think about World War I aviation, the picture that usually comes to mind is, flimsy single-seat biplanes, the classic dogfighters swirling over the trenches.
Snoopy and the Red Baron kind of stuff.
Exactly. But operating right alongside those tiny, maneuverable aircraft, Germany was actually building absolute behemoths. I mean, the largest warplanes of the entire conflict.
Okay, let's unpack this. Because defining what actually makes something a Riesenflugzeug is crucial.
Yeah, the term itself just translates to giant aircraft in German.
Right, but the German military used it as a very strict technical classification. It wasn't just a nickname. To actually qualify for the R class, a bomber had to have at least 3 aircraft engines.
So they usually had 4 or more.
Right, and their payload capacity had to be significantly larger than the standard heavy bombers of the time, the Grossflugzeug.
Like the Gotha GV.
Exactly. But what completely blew my mind in the article you sent us, and this is a staggering piece of context, the R-planes that bombed London during the First World War were actually larger than any of the primary German bombers used decades later during World War II.
Which is wild when you think about the timeline of aviation. The Luftwaffe in the Second World War had large planes, sure, but they were mostly transports or maritime patrol. The World War I R-planes were true strategic bombers built on a scale that just defied the materials of the time.
They were building outward instead of upward with engine power.
Yeah, because early engines were weak. If you wanted to lift a heavy bomb load, you needed immense wing surface area. And Germany wasn't alone in this. It was an international arms race.
This source lists the Allied equivalents, and everyone was trying to build these giants.
Yeah, the direct inspiration for the German program was actually a Russian plane, the Sikorsky Ilya Muromets.
Right, with a wingspan of 29.8 meters.
Exactly. That proved you could build a multi-engine giant and keep it in the air.
Then Italy stepped in with the Caproni Sackway 4. That one marginally beat the Russian plane with a 29.9 meter span.
It's just inching past them.
Totally. And the British weren't sitting out either. They had the Felixstowe Fury, which was this one-off flying boat that hit 37.5 meters, and the Hanley Page V1500 stretched all the way to 38.41 meters.
But the absolute peak of this specific era, the undisputed record holder, was German.
The Siemens Schuckert R8.
Built in 1918.
And its wingspan was 48.0 meters, almost 160 feet.
Which is staggering.
Just an ocean of timber, bracing wire, and fabric stretching across the sky.
And here's the craziest part about that 48-meter wingspan. It took a full 16 years before any other nation built an airplane with a larger wingspan.
16 years.
Yeah. It held the record until the Soviet Union built the Tupolev Maxim Gorky in 1934, and that was a 63-meter wingspan, but it was a much later monoplane design. For a wooden wire biplane from 1918 to hold that record for that long just shows how far they were pushing the engineering.
But pushing the size was just one part of the headache.
Oh, absolutely.
Because there was a specific rule from the German military that made the R class an absolute nightmare to design.
What's fascinating here is that defining mandate. It wasn't just about having 3 or more engines. The military demanded that those engines had to be serviceable in flight.
Here's where it gets really interesting.
Yeah.
You have to picture the reality of 1915 engines. They were, frankly, terrible.
Very unreliable.
They overheated, they spewed oil, they seized up. If you are flying deep into enemy territory and an engine dies, you can't just land in a field.
Right, you become a prisoner of war.
Or worse. Exactly. So the military said, fine, if the engines are going to break, the plane has to be a flying workshop so mechanics can fix them in the air. And to solve this, the engineers split into 2 totally different design camps.
Right, let's look at design 1 first. This group approached the bomber almost like it was a naval ship.
An airborne submarine, basically.
Yeah. They decided the safest place for the engines and the mechanics was inside the fuselage, centralized. So they mounted these massive heavy engines in the belly of the plane.
But then how do you turn the propellers?
That was the catch. They had to invent this insane system of gearboxes and long metal drive shafts running from the center of the plane out through the wooden wings to spin remote propellers.
Which is a mechanical disaster waiting to happen. The source notes that in practice, this power transmission method was incredibly troublesome.
Troublesome is an understatement.
You've got rigid, high-speed metal shafts spinning inside flexible, vibrating wooden biplane wings. The harmonic resonance alone would tear the gearboxes apart. The friction, the twisting, it just didn't work.
The material science of the day just wasn't up to that kind of precision. Which brings us to Design 2.
The pragmatists.
Exactly. They scrapped the internal engine room and the drive shafts. They went with conventional setups. They mounted the engines directly out on the wings in large nacelles or on the nose, direct drive. The propeller is attached right to the engine.
But they still had to follow the military rule. The engines had to be serviced mid-flight.
Yes. So their solution was to build the engine nacelles out on the wings, large enough to put a person inside.
I just can't get over this detail. They actually stationed mechanics inside these wooden pods, out on the wings, sitting next to a roaring engine during the entire flight.
It sounds like fiction, but it was standard practice for these planes, and the direct drive method actually won out. The most successful model of the entire R-class used this design.
The Zeppelin-Staaken R.VI.
Exactly. 18 of them were built, which is a massive production run for the R-class. And they weren't just test models. They actively bombed the Western Front.
18 units really is a huge success when you look at the rest of the list in the source, because almost all the other planes were one-offs.
Just a menagerie of monsters.
Truly. I mean, imagine you're a soldier in the trenches and you see one of these bizarre multi-engine wooden castles lumbering overhead. But because they were mostly experiments, the outcomes were often incredibly tragic.
The trial and error phase was brutal. Take the AEG-RI, for example. Built in 1918. It literally broke up in midair.
The aerodynamic forces just ripped it apart.
Yeah, structural failure. And it was so bad, they instantly abandoned 7 other airframes of the same model that were currently being built.
Just pulled the plug completely. We see that same fatal structural issue with the Siemens-Schuckert-Forstmann R.
Ah, the Forstmann.
This thing was an absolute mess. It was used as a trainer starting in 1915. It had this weird, unbalanced engine setup. 2 smaller engines, and 2 massive ones. They had to rebuild it over and over again before the military would even let it be used just to train pilots.
And its final fate.
It was scrapped because the fuselage just snapped in 2.
Just broke its own back.
Broke its own back under the weight. But instead of dialing it back, designers kept pushing for even more absurd extremes. Look at the Mannesmann giant triplane.
Oh, the Mannesmann. The sheer hubris of that design.
If 4 engines are good, why not 10?
10 engines on a triplane.
Yes. The blueprints called for a 50-meter wingspan to carry 10 individual engines. Thankfully, it was canceled before they could finish building it because the war ended. The drag alone would have made it a brick.
And then there's the Link Hofmannsche. This one actually flew in 1919. It only had 4 engines, but it drove the largest single propeller ever built for an aircraft.
6.9 meters in diameter.
Nearly 23 feet across. Just one massive blade.
Think about the engineering nightmare that creates. The gyroscopic force of a 23-foot propeller spinning on the front of a wooden plane. Every time the pilot tries to turn, the physics want to rip the nose off.
Not to mention just trying to take off. You need incredibly tall, scaffolding-like landing gear just so the propeller blade doesn't strike the dirt.
Right, which adds tons of drag and weight. It's just solving one problem by creating 3 worse ones.
Exactly. But it's important to note that this whole R-class obsession wasn't just for land-based bombers. There was the whole subcategory of flying boats.
The Zeppelin-Lindau R series?
Right, the R's, all the way through the R-SIFs. These were designed for long-range maritime patrols over the ocean. And there is a great historical connection here. These giant flying boats were developed by Claudius Dornier.
While he was still working for Zeppelin.
Yes. He used the R-series to figure out the complex math of multi-engine seaplanes. The R-SIF actually had a 37-meter wingspan and was evaluated by the military in 1917.
So he took all the hard lessons he learned from these World War I wooden giants managing water landings, the corrosive sea air, the structural stress, and applied that directly to his famous interwar flying boats.
Leading right up to the massive Dornier Duex.
That's a great through line. Now, organizing all of this chaos, all these competing manufacturers and experimental prototypes, took a massive amount of bureaucracy.
The German military had a dedicated department for it. The Idflieg.
The Inspection der Fliegertruppen.
The inspection of the Air Force. They managed the funding, evaluated the prototypes, and tried to enforce some level of standardization on this fleet of weird machines.
And their naming convention reflects that. It was incredibly rigid but simple. Any plane that met the giant, multi-engine, in-flight serviceable criteria was an R.
Followed by a period and then a Roman numeral.
You're right. So that Zeppelin-Staaken we talked about earlier is the R.VI because it was the sixth accepted model from that manufacturer.
And for the seaplanes, they just added a lowercase s.
So Dornier's third flying boat became the Rs-3.
Exactly. It kept the paperwork clean, even if the planes themselves were a chaotic mess of trial and error.
So what does this all mean? When we look back at the R planes, we're looking at a very brief, incredibly intense window in aviation history.
Just 1915 to 1919.
Right. And driven by the desperation of a global war, engineers tried to basically cheat the slow evolution of technology by simply making things bigger. They pushed wood, canvas, and wire to limits that wouldn't be touched again for almost 2 decades. They paved the way for the heavy, multi-engine strategic bombers that would define the rest of the 20th century.
But this raises an important question, and I think it's something we really need to sit with.
What's that?
The human element. We talked about the engineering mandate for in-flight servicing. We talked about placing mechanics inside the engine nacelles, the direct drive models. But imagine the raw physical reality of being one of those mechanics.
It's almost unimaginable.
You're stationed inside a thin, unpressurized wooden box suspended out on the wing of a biplane, thousands of feet in the air.
Over an active battlefield. Or the freezing ocean.
The air is freezing, the plane is vibrating violently, and right next to you is a massive, unsilenced aviation engine running at full RPM. The noise alone would be a physical assault.
You'd go deaf instantly without modern protection.
You are surrounded by highly flammable aviation fuel, hot oil spitting everywhere, and you're just holding a wrench. Your only job is to keep that temperamental engine running, because if a valve seizes or an oil line cracks, the entire behemoth might fall from the sky.
The psychological endurance that would require. You are crawling around in the freezing dark, totally exposed, knowing the lives of the whole crew depend on you fixing an experimental engine mid-flight.
It's a terrifying, visceral human experience hidden inside the belly of these giant machines.
It really grounds all these massive blueprints and records into a stark reality. Thank you to the listener, the learner, for sending this source in and sparking this deep dive. The R-planes are a fascinating piece of history. To everyone listening, keep exploring the hidden margins of history, and we will catch you on the next deep dive.